Hello, let us prove some examples which based on Legendre function for Legendre polynomials. Example 1, show that Pn of 1 is equal to 1. Let us prove it. The Legendre function is 1 minus 2xh plus h square to the power minus half is equal to summation n equal to 0 to infinity h to the power n Pn of x. Let us substitute x equal to 1. Substituting x is equal to 1. So we get 1 minus 2h plus h square to the power minus half is equal to 1 minus h whole square into minus half, that is equal to 1 minus h to the power minus 1. Let us apply binomial theorem. So this is 1 plus h plus h square and so on, which is equal to summation h to the power n. Here n runs from 0 to infinity. So this is left hand side, and right hand side is, that is equal to summation n equal to 0 to infinity h to the power n Pn of x, that is x equal to 1, so Pn of 1. Therefore summation n equal to 0 to infinity h to the power n is equal to summation n equal to 0 to infinity h to the power n Pn of 1. So comparing left hand and right hand side, this implies Pn of 1 is equal to 1. So we proved it. Example 2, show that Pn of minus x is equal to minus 1 to the power n Pn of x. So let us prove it. Legendre function is 1 minus 2xh plus h square to the power minus half is equal to summation n equal to 0 to infinity h to the power n Pn of x. So this is equation 1. Substituting minus x for x, substituting minus x for x, we get 1 plus 2xh plus h square to the power minus half is equal to summation n equal to 0 to infinity h to the power n Pn of minus x. So this is equation 2. Again substituting minus h for h in equation 1, we get 1 plus 2xh plus minus h whole square, that is h square to the power minus half, that is equal to summation n equal to 0 to infinity minus h to the power n Pn of x, which is equal to summation n equal to 0 to infinity minus 1 to the power n h to the power n Pn of x. So this is equation 3. Comparing right hand side of equations 2 and 3, we get Pn of minus x, that is equal to minus 1 to the power n Pn of x. Proved. Example 3, show that P2m plus 1 of 0 is equal to 0. B, P2m of 0 is equal to minus 1 to the power m factorial of 2m divided by 2 to the power 2m factorial m square. Let us prove. A. We know that since Pn of minus x is equal to minus 1 to the power n Pn of x, for n is equal to 2m plus 1, one gets P 2m plus 1 of minus x is equal to minus 1 to the power 2m plus 1 P 2m plus 1 of x. For x equal to 0, one gets P 2m plus 1 of 0 is equal to minus 1 to the power 2m plus 1 is, that is minus P 2m plus 1 of 0, or twice of P 2m plus 1 of 0 is equal to 0, or P 2m plus 1 of 0 is equal to 0. Let us prove the other part. B. We consider the genetic function 1 minus 2xh plus h square whole to the power minus half is equal to summation n equal to 0 to infinity h to the power n Pn of x. For x equal to 0, for x is equal to 0, the genetic function is, so let us use the binomial expansion. To the left hand side we have 1 minus half h square, then plus minus half into minus 3 by 2 divided by factorial 2 into h square whole square plus, and so on. Then the next term is, then the nth term is minus half into minus 3 by 2 up to minus half minus n plus 1 divided by factorial n whole into h square to the power n, and so on. This is equal to, now we expand the right hand side, that is 1 when n equal to 0, h to the power 0 is 1 and p0 is 1, so that is 1 plus h p1 of 0 plus h square p2 of 0 plus up to h to the power n Pn of 0. Now equating the coefficient of h to the power n, equating the coefficient of h to the power n. Now we have Pn of 0 from right hand side. The coefficient of h to the power n is Pn of 0, that is equal to minus half into minus 3 by 2 up to minus half. Then here we have h square to the power n. We replace n by 2, so that h square to the power n by 2 is h to the power n. So in this case we replace n by 2, minus half minus n by 2 plus 1 divided by n by 2 factorial. Now for n equal to 2m, n is equal to 2m, we have p 2m of 0 is equal to minus half into minus 3 by 2, then minus half, then minus m. n by 2 is m plus 1 divided by factorial m. This is equal to minus 1 to the power m by 2 to the power m, then into 1 into 3 into 5 up to that is 2m minus 1 divided by m factorial. So this is one important formula, p2m of 0 is equal to this much. Further we can write p2m of 0 is equal to minus 1 to the power m by 2 to the power m 1 into 3 into 5 dot dot up to 2m minus 1 divided by factorial m into 2 into 4 into 6 up to 2m minus 4 into 2m minus 2 into 2m. We insert it, then divide it. 2 into 4 into 6 into 2m minus 4 into 2m minus 2 into 2m. So this is equal to minus 1 to the power m by 2 to the power m. Now we write 1 into 2 into 3 into 4 into 5, then 2m minus 4 into 2m minus 3. Here there is also 2m minus 3 here. 1, 3, 5. 2m minus 3 into 2m minus 1. Then 2m minus 2 into 2m minus 1 into 2m divided by factorial m into 2 into 1, then 4 is 2 into 2, 6 is 2 into 3, then 2 into m minus 2, 2 into m minus 1 into 2 into m. This is equal to minus 1 to the power m by 2 to the power m and 1 into 2 into 3 into 4 up to 2m each, that is 2m factorial. 2m factorial divided by m factorial into 2 to the power m, then 1 into 2 into 3 into m minus 2 into m minus 1 into m, that is m factorial. M factorial. So this is equal to minus 1 to the power m by 2 to the power m 2m factorial divided by, this is 2 to the power 2m, 2 to the power 2m m factorial square. p2m of 0, that is equal to minus 1 to the power m by 2 to the power 2m into 2m factorial divided by m factorial square. Proved. Thank you.